Welcome to EPG Pathshala. The wireless medium is open to all, hence it is always susceptible to threats and attacks. GSM being a wireless network is always prone to the unauthorized access to the network and encroachment to the privacy and confidentiality of the users. Therefore, GSM provides strict security measures to ensure the privacy and confidentiality of the users, as well as to ensure that only authorized and registered users get the access to the network. In this module, we will be discussing about these security measures. The topics which will be covered in this module are goals of GSM security, principles of GSM security measures, the access control and anonymity security provided, then the authentication and encryption. So, we will see these security measures one by one. Let us move to the mechanisms provided. First of all, we should understand that the security features should be provided two-sided, that is at the operator level as well as at the user level. Now, at the operator side, it should be ensured that the operators bill the right person. There should be mechanisms to avoid fraud, and the services should be protected from the attacks. At the subscriber sides, the security measures need to be more promising and precise. They should aim at maintaining privacy and anonymity of the user, that is identification and the location of the user should be concealed. Confidentiality of the communication over air should be maintained by providing proper encryption methods, and there should be strong access control mechanisms for the devices. It should also be ensured that only authenticated users should be able to access the network. At the same time, the security features should also adhere to the following rules. What are they? The features or the measures or the algorithms which are available for security should not add much load to voice calls or data communication. They should not increase the error rate. The measures or the algorithms should not increase the complexity of the system. They should not demand with more bandwidth, that is they should comply with the available bandwidth. The measures should be useful and cost efficient. Given are the outlines of 4 basic principles of GSM security. So, GSM provides the security under following 4 headings. First, access control to the SIM card. This is done by the use of the PIN number and PUK number. Second is maintaining the anonymity. This is done by using the TMSI for IMSI. Third, authentication of subscriber so as to ensure that only registered and authorized user have access to the network. Encryption of data and signal to protect them against interception. Now, we will see that how security described in the above outlines are implemented by GSM network. First, look at access control to SIM. SIM or subscriber identity module. It stores confidential information which can be personal as well as network specific. It stores IMSI number which is used to access the account of the subscriber. It stores 128-bit root encryption key. It stores A3 and A8 algorithms which are used for authentication and generation of cipher keys, which we will be discussing shortly. Therefore, it is very necessary to protect the SIM card. GSM provides provision of SIM card by a PIN identification number, it is PIN. The user needs to know the PIN to unlock the SIM card. SIM card automatically locks out if 3 unsuccessful attempts by feeding the wrong PIN have been made. In this case, a PIN unblocking key, that is PUK, is provided by the operator. If PUK is entered incorrectly a number of times, normally the number is set to 10, the access to information is refused permanently and the SIM becomes useless. So, this is how the control to the access to the SIM card can be provided. The next security measure is maintaining the anonymity of the user. that is hiding the identity and location of the user. This is done by using a temporary mobile subscriber identity number in place of the IMSI number. TMSI is provided by Authentication Center after application of authentication and encryption procedures, but it is only valid in the area of associated MSC, that is it will be valid only till the user is in the area of MSC. For communication outside location area, it is used along with location area identification. TMSI contains 4 into 8 bits, that is it consists of 4 octets, but all 32 bits cannot be made 1, because all 32 bits 1 indicates that there is no TMSI. TMSI is stored in the SIM card and all ones in the TMSI number indicates there is no TMSI. The VLR should be able to correlate the TMSI with the IMSI of the mobile station to which it is allocated. That means, there should be a provision to correlate that this TMSI number is for which IMSI number. Now, another 2 important measures for security are authentication to ensure that only authorized user access the network, and encryption so as to ensure that the confidentiality of data and signals is maintained. Before we move on that how authentication and encryption measures are provided, let us discuss 3 algorithms which has been described in the GSM specifications. These algorithms are known as A3, A5 and A8. A3 algorithm is used for authentication purpose, A8 is used for generation of cipher key and A5 is used for encryption purpose. The GSM specifications for security were designed by GSM consortium in secrecy. The consortium used security by obscurity principles. What does it mean? It means that you can protect anything by hiding, which is meant by security by obscurity. So, the GSM consortium used security by obscurity for the algorithms A3, A5 and A8 initially, which says that algorithm would be difficult to crack if they are not publicly available. Therefore, the algorithms were made available only to hardware and software manufacturers and GSM network operators. But slowly these algorithms were also made public, hence A3 and A8 are not strong enough. So, what can be the solution to it is that the service providers or the users can make these algorithms their proprietary. That is, since A3 and A8 algorithms are stored on the SIM card, the network providers can use their own algorithms or the users can also use their own algorithms for encryption. But A5 algorithm, which is used for encryption, is implemented on the device and it should be identical for all the service providers. It cannot be changed from service provider to service provider or from one user to another user. Only A3 and A8 algorithms can be made proprietary by the service providers or by the users, and they can change accordingly to make the algorithms strong. A3 and A8 are symmetric algorithms using the same key which is embedded on the SIM card. Both are one-way functions, which means that output can be found if the inputs are known, but it is impossible to find the inputs if the output is known, and this is very much required in any security function or security algorithm. Both A3 and A8 use COMP128, which is keyed hash function. COMP128, COMP128, which is a keyed hash function. What is it? A COMP128 function takes 128 bit key and a 128 bit random number as a input and gives 128 bit output. The first 32 bits of 128 bit output forms SRES and the next 54 bits forms the cipher key, which is used for encryption. Now, let us see that how authentication and encryption is performed using the algorithms A3, A5 and A8. First move on to authentication. Authentication requires the following entities and it uses a technique which is known as challenge response method. The entities required are A3 algorithm for authentication, which is stored on the SIM card, as well as it is also made available at the authentication center in the network. It requires KI, which is 128-bit key stored at the SIM card as well as at the authentication center. The KI key is correlated with the IMSI number, that is, looking at the IMSI number, the KI key can be automatically retrieved. It requires random number which is auto generated by authentication center and is provided as a challenge to the mobile station. Following steps are performed for authentication. A mobile station wants to access the services of the GSM network. It sends IMSI number to the network. Network accepts IMSI and find the corresponding KI, which is 128-bit secret key. We have already discussed that there is a correlation between the IMSI number and the KI, because KI is unique to the SIM card and hence unique to the IMSI number. The authentication center generates 128-bit random number and sends it to the mobile station. This is called challenge. The SIM card accepts this challenge and uses the random number and the key KI as input to the A3 algorithm. Now, we know that the SIM card also has a microcontroller to perform the computing functions. It produces 32-bit output using the A3 algorithm, the input KI and the random number. Network also calculates the output using same inputs and algorithms, that is, the SRES will be generated at the mobile station also and at the authentication center also. Now, if the mobile station is genuine, then there should be a genuine KI key. So, the authentication center should be available with that particular key. Now, since the inputs are same, if the mobile station is genuine, that is, key and random number at the authentication center and key and random number at the mobile station. Now, since the inputs are same, the algorithm is same, therefore, the output should also be same. Therefore, the method challenge response says that if the two outputs which are generated by the A3 algorithm at the authentication center as well as the mobile station should match. So, if they are same, then the mobile station is genuine or it is authenticated. Therefore, as a final step, network matches both SRES at its end as well as provided by the mobile station. So, if matched, the subscriber is authenticated. The steps which we just discussed right now are shown in the following activity diagram. You can see that there are three entities: the authentication center, mobile stations and the SIM. Mobile station wants to establish a channel with the network. So, there is a channel establishment link. Then mobile station sends IMSI number to the authentication center. You can see that the authentication center is sending back the random number as a challenge to the mobile station. The SIM card runs the A3 algorithm, because as we said that the SIM card is a computer, it contains a microcontroller to perform the computing functions. It runs the A3 algorithm with the key which it has and the random number which is provided by the authentication center. The SIM generates the SRES, it gives back the SRES to the authentication center. Authentication center matches both SRES to authenticate the SIM card. You can also see the block diagram which summarizes the entire activity of the authentication. It is provided in your PPT slide as well as also it is available in the e-text. Now, let us move to how encryption is provided in GSM, that is how GSM encrypts data and signals. A point to be made here is that encryption is always between the mobile station and base station only, and there is no end-to-end encryption. That is, the data will travel in encrypted form from the mobile station to the base station and vice versa. Therefore, the processes for encryption and decryption will be performed at the mobile station as well as at the base station. The algorithms A5 and A8 are used for encryption. We know that for encryption we need a cipher key. Now, this cipher key is not statically available, it is dynamically generated using the algorithm which is known as the A8 algorithm. Actually, SRES and KC both are generated at the same time. A8 uses Ki and random input and generates a 54-bit cipher key. A point to be remembered here is that though the cipher key used is 64-bit, but the algorithm generates the cipher key only of 54-bit, making the algorithm also less strong. Now, how it is made 64-bit? By appending 10 0 bits to the end of the key. Hence, the 54-bit key is made to 64-bit key. Now, this also reduces the key space from 64 bits to 54 bits and also reducing the strength of the algorithm. These are the following steps which are followed during encryption. Network initiates a ciphering mode request command to the mobile station. Mobile station receives this command. When the mobile station receives this command, the network sends a random number generated to generate the cipher key. Mobile station uses this random number, the key which is available in the SIM card and the A8 algorithm to generate the cipher key and then appends the 10 bits to form a 64-bit cipher key. Now, using same Ki and random number, the network also generates the cipher key and it distributes to the base station. Now, as long as user is authenticated, the KC remains same. That is, the authentication process as well as the generation of cipher key is happening at the same run or at the same time. Okay. So, if the user is authenticated again due to some reason, then the new KC has to be generated. So, during the handovers also, when the mobile station moves from one base station to another base station, and if the authentication is not required again, the same cipher key can be used with the different base station. The only thing is that now that cipher key will be transferred to the new base station with which the mobile is connected now. Now, once the cipher key is obtained, now the plain text can be encrypted with the help of this cipher key to generate the cipher text. So, the data and the signal travels in encrypted form from the mobile station to base station and vice versa. A5 algorithm is implemented on hardware of the mobile phone and A5 is a stream cipher. It works on bit by bit basis. It uses KC cipher key, that is 64 bits, 22-bit function key and 114-bit plain text to generate a 114-bit cipher text. There are many implementation of A5 algorithms available. Most common ones are A50, A51, A52, A53 is for 3G, of which A51 is the strongest one and A50 is literally no encryption. You can find the these variants of the A5 algorithm more in the e-text. So, in this module we have discussed the security measures which are provided by GSM, that is the access control to the SIM card, the anonymity provided to the user, that is privacy and confidentiality of the user is maintained by using the TMSI number. We have discussed the A3, A5, A8 algorithms which are specified in the GSM specifications and which are used for authentication and encryption purpose. We discussed the method of authentication and how it is implemented, and we also discussed that how encryption is implemented using the cipher key and the A5 algorithm. So, in this module we have discussed about the GSM security measures. In the next module we will be discussing how localization and calling takes place in the GSM networks. That is, we need to since GSM allows roaming facility, so we need to localize the mobile phone to provide the services to that mobile phone, and also we will see that how a call is being made, that is when the call is made from the mobile phone, which is known as the mobile initiating call, and when the call comes to the mobile phone, that is the mobile terminating call. So, localization and calling will be discussed in the next module. Till then, thank you.